Welcome back. In our previous lesson, we have considered how we can resolve rational functions into partial fractions. And we have looked at those factors that are repeated. My name is Nana Yawedu, and you can call me Senana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In this lesson, we want to look at how we can resolve rational functions into partial fractions. But we want to consider those denominators that are irreducible, right? So we want to look at irreducible quadratic factors and consider how we can resolve them into partial fractions. Now, let's consider what it means to reduce denominators that are irreducible quadratic factors. So when we have rational expressions, right, with irreducible quadratic factors, what this implies is that, for instance, we can have a quadratic factor s squared plus 1, right, or s squared plus 2, where in this case, when we equate them to 0, right, for instance, we equate s squared plus 2 to 0, we are going to have x squared to be equal to negative 2. Right, when we equate it to 0, we have x squared to be equal to negative 2. And when we want to move on, we can't have factors for them, right? We can find the square root of both sides, where in this case, x will be equal to the square root of negative 2, which is a complex number. So these will not be in factor form, right? So that example, if it's in the denominator, how do we reduce it so that we can decompose it into right, partial fractions? So in this case, we say that if you have as minus b all over as squared plus bs plus c, right, we have to write it as what? Ax plus b all over the irreducible quadratic factor, right? So as squared plus bs plus c. So this s squared plus 1 can be expressed in the form as squared plus bs plus c. Now let's consider an example that makes it clearer. So in this example, we are to resolve x all over x minus 1, s squared plus 1 in partial fractions. So in this case, we have a linear factor s minus 1, and then we have an irreducible quadratic factor s squared plus 1. Right, so let's consider how we can solve this question. So the question given to us is that we must resolve the quadratic expression or the rational expression with the quadratic, right, x all over x minus 1, x squared, right, s squared plus 1, right, into a partial fraction. So we see that, right, it is a linear factor with an irreducible quadratic factor. So we have x minus 1, x squared plus 1. We know for linear, we can express it as a all over the factor. So x minus 1. Right, then for the irreducible quadratic factor, we can use bx plus c, since a has been used for the linear already, all over x squared plus 1. Right, so in this case, we would write the left hand side again, x all over x minus 1, and then x squared plus 1. Then on the right hand side, we have a, right, we take the LCM, so we have to find LCM first, go through the process. So we have our LCM, which is x minus 1, and then s squared plus 1. Then we see that x minus 1 goes into s minus 1. So we have a multiplying s squared plus 1, right, plus bx plus c multiplying, in this case, s squared plus 1 cancels out s squared plus 1, so we have x minus 1. So that implies that we have the denominators to be the same, so we equate the numerator. So we have x to be equal to a multiplying the expression x squared plus 1 plus bx plus c, right, multiplying x minus 1. Right, so we can use a factor x minus 1. So considering, right, x minus 1, to be equal to 0, right, we have our x to be equal to 1. I recommend that in these cases where you realize that when we expand the right hand side of the equations, we'll get a square form of it. You consider the approach where we use the factors. That makes it easier, right? It makes it very easier for us to be able to resolve into our partial fractions. So when x equal to 1, we substitute x equal to 1 into wherever we see x in the equation. So we have 1 to be equal to a 1 squared plus 1 plus b multiplying 1 plus c, right? And then we have 1 minus 1. So this goes to 0. It means that the b part goes to 0. So we will have 1 to be equal to 1 squared plus 1 is 2. So 2a. Right? This 1 minus 1 goes to 0. So the b goes to 0. So it means that we are going to divide both sides by the coefficient of the a, which is 2. And that implies that our a will be equal to 1 over 2. Right? So when we consider it very carefully, we don't have any other factor apart from x minus 1, right? It's equal to 0. So we can also consider picking any appropriate factor. So we can, let's say, x to be equal to -1 because we have used x equal to 1. So let's use x equals to -1. So we substitute x equal to -1 in the equation. That implies that we will have -1, right, to be equal to a, right, -1 all squared plus 1 plus, right, -1 multiplying b, right, and then plus c, then multiplying -1, -1, right? So that implies that we have -1 to be equal to, in the case of this side, we are going to have 2a because -1 all square gives us 1. 1 plus 1 is 2. So 2a. And this side, we are going to have, right, -1, -1 gives us -2. Right, and then we have minus b plus c. Right, so we have -1 is equal to 2a. Negative gives us positive 2b. And then negative positive gives us -2c. Right, but we know that our a is equal to half. So we substitute a into the equation, and we have -1 is equal to 2 multiplying half plus 2b minus 2c. So that implies that we are going to have -1, right, is equal to 1 plus 2b minus 2c. So it implies that we will have 2b minus 2c to be equal to, when the 1 goes to the other side, it becomes -1. So -1 minus 1 gives us -2. Right, so let's call this equation 1. So now that we have equation 1, we are going to consider s to be equal to 0 as well. So what we do is that we just pick factors. So we pick factors that are appropriate, smaller factors that will help us to be able to find our a, b, and c. Right, so we are picking s to be equal to 0. That implies that we have 0, right, so to be equal to a 0 squared plus 1, right, plus, so it means that the b goes to 0, so we have c, right, multiplying -1, right, so 0 multiplying -1 will be -1, so we have 0 to be equal to a, 0 squared is 0, so 1 multiplying a is a, and then minus c, right? So this implies that from this we can have, right, a to be equal to c, and then since our a is equal to half, then it means that c will be equal to half, right? So now that we have a and c, we'll consider the equation 1. You know that equation 1 says that 2b minus 2c is equal to -2. So we know that we have gotten our c already, which is half. So we substitute c into the equation. We have 2b minus 2 multiplying half is equal to -2. So we have 2b, this cancels this, we have -1. So -1 is equal to -2. We have 2b is equal to -2 plus 1. Right, so we have 2b is equal to -1. So we divide both sides by the coefficient of the b, which is 2. And then we have our b as well. So b is equal to negative half. So now we have our a, we have our c, and we have our b. So now we can rewrite the expression, right, in partial fraction form, right? And that will be x all over x minus 1, right, s squared plus 1 to be equal to, we see that a is half, right? So it means that we have 1 all over 2, right? X minus 1. So you can write the half, we write the 1 at the top and then the 2 down. Right, now we have negative half here. So we have minus, right? In this case, we have 1 multiplying x. So b multiplying x. So x in this case. And then we have c being also half. So x, we have plus 1, right? All over. So that is x squared plus 1. So this is our partial fraction result. That implies that we have been able to put it in a form that is simpler for us to be able to work in, right? So we can as well probably put 1 here, right? So 1 can be here, or since it is in a bracket, we see that we can also ignore. So 1, right? So 1 over 2 multiplying x minus 1 minus 1, multiply the expression x plus 1 all over s squared plus what? 1, right? So this is resolved using the decomposition of the partial fractions. So basically, we've gone through the process to resolve a partial fraction. I'll leave you to do this. Try and solve this. Try and resolve the partial fraction here, right? Or resolve in partial fraction the expression here. So we have an expression 4x squared minus 4x plus 1 all over x minus 2, 2x squared plus 1. So resolve it in partial fraction form. We see that we have a linear factor, then we have an irreducible quadratic factor. In our next lesson, we would want to consider how we can resolve rational functions to partial fractions, where in this case, we will consider those rational functions where the numerators have a higher power than the denominator. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.